Select the major product of the following reaction. So we can see that our starting material is a ketone, and it's a ketone that has an unsaturation that is conjugated to that carbonyl. And it's between the alpha and beta carbons. So we call this an alpha beta unsaturated carbonyl. Specifically a ketone in this case. And so with these, we have two electrophilic sites. So we have an electrophilic site at the carbonyl carbon and an electrophilic site at the beta carbon. So we have two electrophilic sites. And so what we need to know is that our really strong bases and hard nucleophiles, like Grignard reagents, add to the carbonyl carbon. Your nucleophiles that are weaker bases add to the beta carbon. So we expect that this Grignard reagent will add to the carbonyl carbon just like any other time we've seen a Grignard with a carbonyl. So we will attack that, and it's going to form a single bond to oxygen. And so after that first step, we will see that we have the oxygen with a negative charge, right? Because we push these pi electrons up. We formed a new bond between this CH2 of our ethyl group and that carbonyl. So we've added a 2-carbon atom chain, and we still have that alpha beta unsaturation. And in the second step, we're going to have a proton source. And so we have H3O plus listed here. You might see this to be water or even an alcohol. And so H3O plus is, you'd have to assume that it would be a very, very weak concentration of acid because otherwise it could react with your alkene. So don't be surprised if you see instead of H3O plus water or even an alcohol like ethanol. So we have a proton source of some kind, and you're going to protonate that, and so that you would get the tertiary alcohol. And you would still have that alkene intact, and we can see that that matches answer D.